Welcome to Weather Geeks. I'm Dr. Marshall Shepard from the University of Georgia, but I'm not at the university right now. We're on Mars, and if you take a look at our set here, we've got some amazing Martian footage because I am here with Dr. Tanya Harrison, and she is a planetary scientist at Arizona State University. And Weather Geeks fan, we're talking Martian weather today. This is what the show's all about. I'm just really excited about this show. I want to give a shout out to Dr. Tom Gill for making this happen. Describe Martian weather, because I think people may not realize that it does have weather just like Earth.
It does, and it's very active, and I think that's something that people are really surprised to learn. Mars has dust storms, it has water ice clouds.
It has dust devils even, right?
Dust
I
devils,
think
like
we even
little
have some
tornadoes.
footage of some of those like little tornadoes. Why do they form?
They're just little disturbances that form the same way that you would have them on the Earth, and they're almost like miniature tornadoes.
Yeah, but not necessarily like many of our Weather Geeks viewers may be thinking about these large supercell generated tornadoes that spin out. These develop really more from disturbances heating on the surface, kind of like our land spouts or maybe even dust devils here on the planet.
Yeah, that's generally how they tend to form on Mars. So they're usually relatively small, but we have seen some that are on the scale of the size of terrestrial tornadoes.
Yeah.
Not very often, but we do have some really impressive pictures of those.
And how long have we been studying? I know we're going to get into some of this, sending rovers to Mars, and all kinds of data and instruments are being collected, but how long have we been collecting information on Martian weather?
On weather specifically, the first instrument that we sent to really study weather in the orbit of Mars was the Mars Orbiter Camera Wide Angle, or the Mach Wide Angle Camera. And its job was to take full daily mosaics in color of the entire planet to take a look at the weather over time. This was on the Mars Global Surveyor spacecraft, which stopped operating in 2006, but it ran from about 1997 through 2006. And then in 2006, overlapping with that a little bit, we had the Mars Reconnaissance Orbiter, which has a camera on board called Marcy, the Mars Color Imager. And this is another one specifically meant to monitor the weather on Mars by taking daily global mosaics. This one operates at a different resolution than the previous camera, but it still gives us the same kind of data.
Right.
So we have basically a full color global mosaic of all of Mars for almost every day between early 1998 and now. And
wow.
that's incredible. We don't have a data set like that for Earth, much less any other planet besides Mars. So it's really fantastic data set.
Right. Now, I want to kind of get back into the weather, because I think most weather geeks and anyone that's taken a basic class in weather understands that here on Earth, the sun and sort of the differences between the tropics and the poles create differences in temperature. You get thermal gradients and you get these large circulations. What's governing the weather on Mars?
So the two main things that control what happens on Mars are temperature gradients and topography. So we see a lot of weather systems that tend to hang out around the edges of the polar caps, which themselves grow and shrink with the seasons. Sure. Because they get frost deposited around the edges, quite significant amounts of it, all the way down to the higher mid-latitudes in fall through winter, and then in spring that starts to sublimate away, and you end up with...
Describe the term sublimation for those that may not understand what that means. We love those terms, but we just like to make sure they understand them as well.
Yeah, so on Mars, liquid water is not stable, so it tends to go directly from vapor to solid or vice versa. Right. So we have solid frost that deposits on the surface in late fall into winter, and then that frost goes back into the atmosphere in the form of water vapor when springtime comes around. And
that was actually a question I was going to ask. Does Mars have seasons? And if so, are they similarly governed by this notion of orbiting the sun and the tilt of the axis the way we have on Earth?
Yes, conveniently, the tilt of Mars toward the sun is really similar to that of the Earth. It's only about a couple degrees difference. Mm-hmm. So the seasons are really similar. They just happen to be about twice as long because the Martian year is about twice as long. But we see a lot of similar types of weather patterns that you would get in, northern hemisphere spring on the Earth versus Mars, things like that. Now,
I've read about and seen this term SOL, or the SOL. What is that?
Sol is just the Martian day.
Okay, so that's actually the Martian day. What are the temperature range? I mean, I think we have a sense of what the range of temperatures are here on our planet. What's the sort of range of temperatures that we can experience on Mars?
At its coldest, if you get toward the poles in winter, it can be down to negative 180 Celsius.
Yes.
And on a nice balmy day near the equator, you can get pretty close to freezing.
Right.
So
a warm day on Mars is freezing.
Yeah.
32 degrees Fahrenheit or 0 degrees
Yeah,
Celsius.
it's pretty much like Canada.
Sure. Now, which you are originally from Canada, I understand. Is that right?
I
Or-
just moved back to the States from Canada.
That's what I thought, yeah. Now, is there lightning on Mars? Are there hurricanes? Any kind of what we would consider extreme weather?
So we've been looking for lightning for a long time, mostly doing monitoring on the night side of the planet, and there hasn't been any real conclusive evidence that it's there, unfortunately. The biggest type of storms that we get are these dust storms that can become big enough that they would be, the size of the entire United States.
Oh, wow.
And sometimes you can have multiple storms like that merge together, or if they manage to cross the equator, that's usually the danger sign. These tend to form in the northern hemisphere. There'll be these spiral storms that hang out around the northern polar cap, and they eventually end up sort of swinging off into these low topography areas, so big basins. And then they'll move south, and generally by the time they hit the equator, they'll dissipate. But sometimes they go past the equator and they can make it all the way to the edge of the south polar cap. And that tends to be when we get one of these global dust storms that
Wow.
Mars is famous for.
And that's a little bit of a different process than some of the types of things we see on Earth with a lot of this cross-equatorial action that you're talking about.
Yes, definitely.
Yeah. Now, Weather Geeks viewers, I know you're probably familiar with the composition of our atmosphere. It's mostly nitrogen with some oxygen and trace gases. Curious, what is the composition of Mars' atmosphere?
So Mars' atmosphere is about 95% carbon dioxide, and the rest are trace amounts of things like nitrogen, carbon monoxide, water vapor, and argon.
Now, that's interesting. So with this 95% CO2 atmosphere, does that in itself create any interesting radiative effects on the planet in terms of, because here on Earth we have a greenhouse effect, for example.
Yeah, right. So the atmosphere is so thin that it doesn't really get much of a greenhouse effect, even though it has so much carbon dioxide in it. It's just
So
too
it's
thin.
a matter of the thickness here of the atmospheres between our two planets. That's why, because I can sort of hear some people saying, see, they've got a CO2 atmosphere, but it's not warming there. So it's related to the thickness and thinness.
Yeah, and things like the atmospheric pressure. So for comparison, Earth is 1 bar of atmospheric pressure. Mars is 6 millibars.
Okay.
So there's an atmosphere there, but there's not a whole lot of it.
Yeah, and I think that's a key point. But when we come back, not only are we talking about the atmosphere of Mars, we're going to talk about predicting Martian weather. But first, our Geek of the Week.
Dr. Tom Gill, professor of environmental science at the University of Texas, El Paso, is this week's Geek of the Week. He's been studying dust storms for over 30 years, and his most memorable came back in March of 1993. No surprise in the downtime, Dr. Gill enjoys landscape photography. Congratulations, our Geek of the Week, Dr. Tom Gill.
We're talking Martian weather on Weather Geeks today. This is, again, I think this is just a prototypical topic for this show. It's just a fascinating topic. But I want to get back to, we're talking with Dr. Tanya Harrison, by the way, from Arizona State. I want to talk about the Martian atmosphere again, because there's evidence that it's being sort of stripped away, blown away.
Yes.
Yeah, what's going on with that?
So for the longest time, we didn't think that Mars has a magnetic field, and because of that, it doesn't have any way to protect its atmosphere. And so we theorized that the atmosphere is very thin today compared to how it was in the past, when it would have had to have been thicker to support things like giant outflow channels and possibly oceans that we see evidence for on the surface, but couldn't possibly exist under the conditions on the surface today. But we recently sent a mission, NASA did, called MAVEN, to study the atmosphere of Mars. And MAVEN has actually measured the rate of atmospheric loss with the solar wind blowing away the atmosphere. And it loses something on the order of about 1/4 pound per second, which sounds like a lot, and that's pretty significant.
Yeah, I want to give a shout out, by the way, to my good friend Lisa May, who was one of the project executives at NASA on the MAVEN mission.
Oh, she's fantastic.
Yeah, so she's a really good friend of mine. Now I want to come back to this notion of predicting weather on Mars. Now here on Earth we use computer models and simulate the atmospheric flow, the dynamics. Is that how it's done on Mars? Are there models, is there data collected that is fed into the models to run the models?
Most of the modeling that we tend to do is for Mars in the past, when we want to think about, okay, what could the atmospheric conditions have been like before to support, as I mentioned, these oceans and giant river valleys and things like that, that we can't explain under today's conditions. For predicting weather today, it's mostly just been looking at patterns over time. So because we have this long record of continuous monitoring between the Mars Global Surveyor and the Mars Reconnaissance Orbiter spacecraft, plus some not weather-specific measurements, but we do have some weather data from older missions such as Viking and Mariner that went back in the 60s and 70s to Mars. We can put those pieces together and paint a picture of what types of weather occur in what places on Mars at certain times of the year.
Yeah, so you're sort of using retrospective analysis and modeling to sort of prognosticate the forecast instead of just sort of advancing forward in the way we do.
I think we just don't have enough data for Mars yet to be able to do those kind of models, so we're still in the kind of observe and see what happens stage.
Now, we have some rovers on Mars, and that's been a really great success story of our space program. Do these have any atmospheric sensors on them that are helping collect some of this data?
They do have some atmospheric sensors where they can collect things like wind speed, relative humidity, temperature, things like that. So we're working to put the pieces together between what we're seeing on the ground versus what we're seeing from orbit. But with the rovers, you're only getting a very localized picture of what's happening in the case of Curiosity, in that particular crater that rover is in.
And what is the history of rovers on Mars? Because you just mentioned Curiosity. I mean, are there others there now, or?
So there's two that are still operating. Curiosity has been there since 2012, and the Opportunity rover has been going strong for almost 13 years now. It's the rover that won't die. It's supposed to last 90 Martian days, 90 sols.
Oh, wow.
And it's still going strong now. And we actually have weather to thank for this because it's solar powered, and dust over time from the Martian atmosphere collects on the solar panels. And serendipitously, little dust devils have come by and blown the dust off the solar panels.
Yeah.
So those have been saving this rover for all these years. It's fantastic.
Wow. So in some ways, the weather, very Martian weather that we're talking about now, has preserved some of this rover's capacity.
Yeah, it's fantastic.
Yeah.
And it's not something we ever would have expected to happen.
Well, and that's, having been in NASA myself, that is often the case. When we get back on Weather Geeks, mission to Mars, we're hearing a lot about it. There's a lot of movies about it. How close are we to that? And what role will Martian weather play as well? After the break on Weather Geeks. And welcome back to Weather Geeks. I'm talking Martian weather with one of the world's experts on the topic. Now, mission to Mars, there are all kinds of movies, there are television documentaries and specials on now. That's probably going to happen perhaps in my lifetime, or at least in my kids' lifetime.
I hope so.
What will it take to get there, and will meteorologists be involved?
So it's mostly advancing the technology at this point. We need the technology to get there in a reasonable amount of time, and we need to understand how the human body will respond to living in conditions like that, both on Mars as well as experiencing the conditions for the time it would take to get there.
Right.
Once they're on the surface, I can't see direct ways that meteorology will be affecting things other than perhaps picking places where we don't want to build a base.
Sure.
These large storms I mentioned before, they tend to happen in very specific places, and so we know very much to ignore them. Like we wouldn't send rovers to a lot of those places.
So you're going to have some type of meteorological or Martian climatological analysis to determine where you might want to put these sort of permanent or quasi-permanent bases.
Yeah, you want to make sure you're somewhere where you're not going to be in any danger, but you also want to be somewhere hopefully scientifically interesting, so you have to weigh these two against each other.
Just how long does it take to get to Mars, given the technology that we anticipate will be in place over the next couple of decades?
Right now it takes 8 months, which is pretty quick compared to almost anywhere else you would want to go in the solar system other than the moon. But that's still a long time for a human to be in space. And right now, we have humans living on the International Space Station for longer than that, but they're still very much protected from things like cosmic background radiation because they're within the magnetic field of the Earth.
Right.
Once you leave that, there are a lot of terrible things that can happen to you. So we have to figure out ways to be able to mitigate the damage from that if we're going to have people moving out there, especially if Mars also does not have a magnetic field. We still need to be able to protect our astronauts on the surface of Mars.
Exactly. Now I want to put you on the spot a little bit because you're the expert. We've been geeking out the entire show. And I mean, of course, I know that this is an answer that may or may not have an answer, but when do you think we're going to get there? When do you think this mission's going to happen? How many years from now?
So NASA's goal is the 2030s.
Okay.
I'm hoping that that will actually happen, but I feel like a lot of dates have come up and then get pushed farther and farther back. When I was in high school, NASA had a project called the Mars Millennium Project where they were envisioning humans colonizing Mars by the year 2030. The latest thing that I saw is, well, we might send humans to Mars orbit by the early 2030s. So not even landing, just sort of flying by and then coming back to the Earth, which is not quite the same.
Right. Now, the Martian, the movie Martian, and some of the things we're seeing now on some of the other networks, do you think they're fair depictions as best we can of what things would be like, or are they sort of dramatized or Hollywoodized, if you will?
There's definitely some drama added. The Martian, to its credit, is pretty scientifically accurate, other than the strength of the dust storm at the beginning,
Sure.
which the author of the novel that the movie is based on admits was a story point.
Oh, we've got plenty of meteorological movies that kind of take liberties with drama.
Yeah.
Sharknado, anyone?
We don't have those on Earth?
No. Yeah. So if NASA came knocking on your door, would you sign up to go as a part of the first missions?
Part of me says yes, I would really love to, but the claustrophobic part of me says no.
Yeah, right. Yeah, the reality of it all. I mean, as much as I love hurricanes, I'm not necessarily sure I want to fly through them, but we certainly have colleagues that do that.
Yeah.
Last question for you. How did you get into this? How does someone become a Martian expert like yourself in 30 seconds?
So actually this Mars Millennium Project that NASA was working on, they had a call for kids to design colonies on Mars in the year 2030, and I got super into it. I was contacting people in aerospace companies nearby where I lived, asking them questions about designing bases, and joined up with the Mars Society chapter where I was growing up, and they helped connect me with people at the local university, and it just grew from there.
And there you see that Martian geeks are just like weather geeks. They get involved at an early age. And that's really where we're going to have to end it today. Such a fascinating show. We're here every Sunday at noon. We're also on Twitter, WX Geeks TWC on Facebook. See you next week on Weather Geeks.